Hello everyone, good morning. If you see the video in the morning, good morning. If you see it in the evening, good evening. And my name is AHMAD HUSSAM. My student number is 21102195527. And this video for the last homework in the microprocessor and microcontroller. Let's see the question. Give me the minutes, 1 minute here. Okay, let's read it together. Okay, there is a cream package. Okay, reduced moving band move until that below filling tab. Okay, there is a filling tab and package that it's position sensor for filling tab. There is a sensor for a filling tab and for 0.5 seconds. Then walking belts continue. It will be continue to the rotation, I think, rotation part. Then it will be raised until the color sensor detects the color squares on the package. Okay, the motor stop and lower side of the package is pressed with upper press. Okay, there is some of pins, okay, or we can say it's PIN. Okay, for filling tab it's port 1.0, and for rotating sensor is port 1.1, and for color sensor it's port 1.2, and belt motor and so on, filling tab and press and rotation motor. There is some of as we said, some of ports. Okay, let's go to the code. Let's start, okay, with origin 00 hex. I didn't take it. Okay, let's debug. Okay, here is jump x. So let's start to explain the concepts here. So we will use PN. Okay, right? So we will use timer or counter. So because he didn't give us PN from port 3 or from port 3.5 like that, or port 3.4, port 3. It's like that. It's always for the counter. Okay, and the another reason, because we have 0.5 millisecond, 0.5 second for the pelt goes to the rotation. It's 0.5 second. For this reason we will use timer. Okay, for this reason. So we should use the machine cycle. Why? Because for using the timer we should use machine cycle. Okay, then T mode. How we get this number for T mode? Okay, we choose what TC or T timer for counter 0. We chose it. We can choose timer for counter 1. We have two figure, okay, or two choices. Okay, so for TC 0, for the figure we can see it. Okay, we can see it together. Okay, for T mode, the high nibble we didn't care about it. The low nibble we will take it and get it in our solve or in our controller. Okay, so we have a gate. Okay, gate for hardware or software. So we will use the software. Why? Because we didn't give this question didn't give us information about hardware, so we will use software. So for this reason, gate is 0, we will use software. So for this reason, we put here after the high nibble, we put it 0. And then we have after the gate, okay, CT 0. We will use 0 or 1 from the figure. We will use 0 because we will use the timer, okay. Then we have the modes, okay. So we will use which mode we didn't know until now, okay. If we as we said, we will use machine cycle. So in the machine cycle, for 10 megahertz, okay, we'll use 1.2 microsecond, okay. So we have 0.5, and if we calculate it, okay, 0.5, and in the one machine cycle for 10 megahertz, okay, we will use 1.2 microsecond. If we put it in the calculator, okay, how we get in the last question, 42073, okay, decimal, okay. We will save it, okay, and absolute we will this after the minus, because we'll use 60-bit. Why? Because we have a large number, okay. So if we use one timer, it's so it will be crush this code or this program. So it will be so bad work for this timer. We should use it 7 times because it's large number, okay. So if we minus this number from 60-bit, so we will use in the finally mode 0.1 0.01, okay, for 60-bit. So in the last here in the code, okay, if we see it, 0.1, okay, so for 60-bit, and this is the higher mode. It's in bits, okay, it's 65535, okay. Then for this number we get it, okay, we will get it choices, okay. We have 2 choices. We can transform it to hexa and transform it to high th, okay, or t low, okay, t high 0 or t low 0, okay. Or we can put it to transfer to data pointer as a decimal, okay. So as we said, it's a large number, so we will put this we divide it, so we divide it over 7. For this reason we need it 7 times, okay, 7 times for the timer. We can put it for transfer the data, or for the timer you will get it this data, okay. So 7 times we will put it in the register 7 decimal, as we can say. We will use a call timer, okay, a call timer. Where is the timer? Is here. Okay. For this mode, we can or not we can, we should every time or not every step, we can say every format or every if we go 5 comments or like that, or 6 comments, we should or in the last comment, we should reminder for TL0 and TH0. So we should use a call for every time. We will reminder for TL0 and TH0. Okay, so we put it in data pointer. It's right. So the low one, the low nibble, will goes to the T low nibble, and data pointer high, it will be to timer high 0. Okay, so we will go to the GNB jump if is not but bit is not 1, so it will be goes to this address. Okay, if is it 1, it will be goes to this comment, and it will be clear. If it is 1, it will be clear. Okay, then set ptr0. Okay, this tr0 for what? For tcon. And as we get in the lecture, tcon, it can be bit addressable, and for tmode it cannot be bit addressable, so we put it like byte addressable for tmode. For tcon, we can use set b or clear tr0. So let's move on and set port to sorry, why we set port 2.0? Port 2.0, it built motor, okay, for the crane packages. Okay, so it will be move on. Okay, then for port 1.0, failing tab. So if the sensor have get this sensitivity, or this sensor, if this failing or this crane packages, it's failing, so it will be move on to the rotation and go on. Okay, so we will go to set port 2.3 for what? For failing tab motor. Okay, this is for sensor, but here for motor. Okay, this is we didn't mention. So we will, after we as we said here, we put what? tr0 and tcon of tcon 0, we should use tf0 over flow flag. Okay, after GNB jump if not bit is 1, goes to this address. It's if it is 1, it will be goes to this and clear, and again not again, we will decrease the register. It will be 6 and 5 and 4 and 3 and go on, move on. Okay, then clear port 2.3, clear port 2.3, it's failing tab motor. Why we clear it? Because we will go to the rotation. After we get the register in 0, then we get it again. Why we get it again? Because we will use what's its name, belt motor. We will use belt motor. The main motor is belt motor. For this reason, we will use twice for the TL0, okay, and for timer low 0 and timer high 0, and for register, because this twice, this two reason we will re-mention, okay. We mentioned again for set B, as we said, board 2.0, it's for build motor, okay, and a call timer for the, as we said here, for TL0 and TH0. Just for notes, okay, in what, in mode 8-bit, okay, we will not re-mention the TL0 and the TH0 or TH1 and TL1 in the last comment, okay, before the sjump X, before the loop, before the end the loop, okay. Here we can re-mention, okay. So a call timer, and we will go to the another main part. It's for rotation sensor, okay. Then we will clear port 2.0 and set port 2.1 for rotation motor. It for in the first we set the belt, okay, move on, and we will use the rotation sensor, okay, rotation sensor, and the rotation motor, it will be set, okay. Then we will complete until here, set B, and blah blah blah. For a call, as we said, there is a ret, okay. For this ret, it will be goes for this a call, it will be under the a call, it will be goes to here, okay. For a call timer is here, okay, timer is move, and for the comment ret, it will be goes this a call, it will be goes under the comment of a call, okay. And let's see the prods for the figure. We will show it here. Give me a minute. So give me a minute, just a minute. Go to the proto switches. We will put or press on the first switch and build. It will be have a light, and for the filling, and it will be for the second switch, it will be for the rotation, it will be have a light, and for the third one, it will be for the press, and build also every time it will be have a light, because for the we have pressed here and here for the second switch, and third also you can see, and again and again for our figure. Thank you for watching, and I hope see you again and again in homeworks, and good luck.